Okay, so here we learn how to find z-score, and this is one of the discussion topic in section 3.4. Now, z-score is a way to measure how far an individual data value is away from the mean, and z-score is measured in terms of in units of standard deviation. And so, if you're looking at data one, let's say, and we are coming up with example 1, we want to find z-score of the value, say 88. Okay, so 88 in the row of data value, it's 88 is one individual data value. Now z-score is a way to represent how far 88 is away from the mean in terms of the number of standard deviations. And so, in a way, how I say it, you can see that for any data set, you need to, in order to find a z-score for any data value, you need to know the mean value and the standard deviations for the whole data set. So now, in my data set 1, in our data set 1, mean value is a 76.3 and standard deviation is a 12.5. And so now, to find a z-score for 88, and a lot of time we use a lowercase, a subscript to indicate z-score of 88. So once again, the letter z, the lowercase z for z-score, and then the subscript 88 is indicating the z-score for that particular value 88. And the way we find that, you take the raw score, which is the 88, the individual score, subtract the mean value, and we divide it by the standard deviation. And so here, in this way, so the raw score is an 88 minus 76.3, and we divide by the standard deviation. So my z-score would be so z-score of 88 is going to be 0.936. And so let's recap before we move away from this example. So what's the meaning of this 0.936 right here? It means the individual data value 88 is 0.936 standard deviations above the mean. Now you can notice the z-score for this particular data value is a positive z-score. And you can see that compared to the mean, this individual data value 88 is higher than the mean, and so it's reflected by the sign of the z-score. The z-score here has a positive sign. And so once again, this positive z-score, positive 0.936, is indicating that the individual data value 88 is 0.936 standard deviations above the mean value. Okay, so now let's look into example number 2. Okay, so example number 2, we want to find z-score again. Find z-score of, let's say, how about a 68? Okay, so once again, we know from our data set 1, the mean value is a 76.3, standard deviation equals 12.5. And so z-score, once again, the z-score for the individual value is 68. So I'm using the notation once again, z sub 68 would be equals to the individual data value 68 minus the mean, and we divide that by the standard deviation. And here this time, in the way my calculation can be done, you can go 68 minus the mean 76.3, you get the answer negative, and we divide that by 12.5, and that gives me negative 0.66. So my z-score is minus 0.66. And a lot of time, as a convention here, I should have done this in the previous example. With a lot of time we are rounding the z-score into 2 decimal places. So here this time my z-score, unlike the previous problem, my z-score this time has a negative signs. And so now how does that explain with the individual data value itself? 68 is a data value that's below the mean value, and so that's why it's all reflected in the sign of the z-score. So here my finalized z-score here is a negative 0.66. It's indicating that 68 is 0.66 standard deviations below the mean value. And so that's how we find the z-score. So now, before we move away from this lesson, let's try to finalize the z-score into the way how to find z-score into a formula. So now z-score for any value is going to be the individual data value that I use in notation x, subtract the mean value x bar, and we divide it by the standard deviation, and that's how we find z-score. Or in short, it's just simply one formula: z equals x, which is the individual data value, minus the x bar, which is the mean, divided by s. That's somehow a shorter way of writing the formula for z-score. And also keep in mind, okay, positive z-score means the value is above mean. And then negative z-score means the individual data value is below the mean.